Guys, so this is a impromptu stream by Mr. Lowe on chapter 6 in biology, just to finish up some notes which we have missed over. Just want to let you guys know, I know that some of you guys have mentioned that in bio we're moving really quick. Yeah, I think that's just, unfortunately, that's just part of the process. It's a lot of content. As you can see, the book is about this big and we have to get through all of it as part of the Victorian curriculum, but we'll keep going. Anyway, last time we had a chat, we talked about the world's most expensive fish, which was the bluefin tuna. And let me just get to my, there we go. Okay, and we're talking about over-harvesting. Okay, so this is the bluefin tuna here. So Japanese people eat about 80% of the bluefin tuna caught worldwide, and it just keeps increasing in terms of demand. In terms of the stock, it fell by 60%. Due to rampant, often illegal overfishing and really relaxed quotas. So people are obviously not really doing the right thing. And at the moment, it's 90% of tuna are being caught before they reach reproductive age. And you just think over time, if fish are being caught before they're even able to reproduce, what happens to the stocks? So this is what the outlook looks like. So this was done in 2008. This is the Atlantic bluefin tuna, and look at this here in 1998. It's just plummeted right down, and it's just continuing down. And this is what we feel like it's going to happen in this year. If you look at this is the amount of lines that have been put out. Okay, so they're putting a lot of lines out, but not many fish are being caught over here. This is just more of a pictorial. This is again how many fish have been caught over the years. Okay, so overall they think that this is where it's at, and I think that in 2012 it would have gone extinct. However, that's not exactly true right now. It hasn't fully gone extinct yet. So with the regulations to protect Australia's fish, there's info to protect species, so where, when and at what age species breeds, its rate of growth and time for it to reach sexual maturity. So this is what you might see, a fishing guide, and this is the brim. So they've got a minimum legal size of 28 centimetres, and what they've done is they've calculated how long this would take for the fish, sorry, let me just do this, how long it'll take for the fish to actually reproduce, and I think at 28 centimetres that it would be fine to reproduce and be able to catch. However, with brim, they're extremely slow growing, so they grow about 1 centimetre a year. So when I catch them, I don't actually keep them anymore because I just feel like they're too precious. Now, there's something called human-induced salinity. So in general, salinity is going to increase naturally in some environments. So whether it's just like a mangrove or something, this is called primary or natural salinity. This means that over time it's always going to go a bit salty. Okay, and sometimes human impact can increase salinity. So sometimes human impact, and this is called secondary or human-induced salinity. And what happens is the salt content of the soil and water increases to such a high level that it damages all the plants and animals, and it happens in a relatively short time as well. So there's two types of how human-induced salinity can occur. One is over here, type 1, then you've got type 2, and we'll explain both of them. Both of them cause the water table to rise where soil deposits reach the land, and I'll show you on the next slide here. Great, so this is the water table. Okay, and if you remove all these trees, this is type 1 removal of trees, if you remove all these trees and you wipe these out, as it rains, the water table increases, okay, and because of that it brings up all this ancient salt to the surface. See how now the water's up here? The salty water reaches the surface and then it settles on top here. Eventually this land will be unable to be used because the salt, which is ancient salt that's been there for years but underground, is now all accumulated at the top. Same kind of thing with irrigation salinity. It's about the water table rising, and it's because of overwatering. So you can imagine that these kind of farms here, they're watering their plants heaps and heaps and heaps. The water table rise brings us all these ancient salt out of underground all the way to the surface, and because the salt is now at the surface, the plants and animals are unable to grow there. There's human impacts on ecosystems, number 3. Now this covers damming of rivers, nutrient overloading, and waste disposal. So with damming rivers, a river that's got no dams or weirs, so a weir is just like something like over here. This is a weir. Oops. This is a weir over here. It's unregulated if it's got no dams or weirs, but sometimes we want to put a dam there to regulate the water. So rivers, wetlands, and estuaries rely on natural flow of water to maintain their biodiversity, meaning that animals and plants they're used to a certain way of the water flowing. And if you release all this, if you do damming and have a water body where all the water starts going in here instead of flowing naturally down here, if you release all the cold water up here, it can be too cold and it might even kill the fish. If you say you've got a river system and you make a dam and all the water goes in here instead, and we might do dams for drinking water or something, or for farming, it might dry out wetlands. Or if you do like weirs, how on earth is a fish gonna go up here? There's no way that a fish can migrate up there to breed. So you might have two separate populations and they might be unsustainable. So over here, this is natural flow of an unregulated river in the months, and this is what happens when we put a dam in there. The flow just becomes very low. Okay. Number 2 is nutrient overloading, and so what happens when we have farming or agriculture? We're putting heaps of nitrates, phosphates, and all these kind of chemicals onto the land. That runs off and goes into the ocean or a waterway and increase the population of algae. We might do this if we, say, release heaps of sewage or something into the water as well. That can increase the population of algae. And the accumulation of dissolved mineral nutrients like nitrogen, phosphorus, or potassium in a body of water is called eutrophication. This leads to a cascade effect which results in depletion of oxygen in water called hypoxia. And this is what it looks like. So this is the water, normal water here, and this is how it's all gone green. Over here, this is all just algae completely covering this lake, and this is what it is down here. So this is the cascade. First of all, you've got farms where you've decided to release heaps of runoff like fertilizer into the river, and then because there's an increase in nutrients, heaps of bacteria start to grow and algae because they're starting to feed on all these nutrients. And then say this is my waterway, all the algae starts to block out all the light, so all the plants down here, they can't grow anymore, so then all the plants die. Okay, so all the plants start to die off, and if the plants die, then you might have death of fish and other animals. And then, over here, don't worry about that. So if the plants die, you have heaps of waste. Okay, and when something is rotting in the water, it releases carbon dioxide. So all that carbon dioxide starts to increase, all these microorganisms start to increase, and they take up all the oxygen. In the end, because there's no oxygen left, you have death of the fish and other animals as a cascade effect that happens there. Waste disposal. So sometimes we don't dispose of the waste properly. This is in China. A worker cleans away dead fish at a lake in Wuhan. More than 50 kilograms of fish died to pollution and hot weather in the lake. So, this gentleman's his livelihood is all on this lake, and you can see how desperate he might be if he's trying to see all this fish all dead, and so he's trying to collect it. So if they start to rot, then it'd destroy the waterway even more. Just a little story. So Shanghai doctors tell local newspaper that 2/3 of the city's semen stocks are below World Health Organization standards as concerns over China's toxic environment growth. So pretty much their sperm is actually depleting in quality because of the pollution. And here's just a picture of, this is the amount of rubbish. I went to Indonesia in the holidays, and even though we're like, hundreds of kilometers out from the beach, there's just rubbish floating everywhere down there, and it's really gross. There's something called the Great Pacific Garbage Patch, and it's just off the coast of Oregon in the United States. This is how big it is, and they reckon it's about the size of Texas. It's just a giant mass of rubbish, and this is what it is from an aerial view. This is all just rubbish from around the world that's all accumulated and just kind of just being brought in by the waves, and then hooks on each other and just stays there. And it's this huge garbage patch of just rubbish and plastic that won't degrade naturally, but needs to be removed. However, there are some positive changes to ecosystems. There's a YouTube video you can watch called How Wolves Change Rivers, and it just shows you when they introduced wolves back into an environment, they were able to actually rehabilitate the ecosystem because they introduced the wolves back in. There's also another story about Mary Hutton. She's very proud to say that she's an Australian, and in 1993, this is just like a grandma. She was just in her TV room and she watched a current affairs video, like segment on Asiatic black bears, which is just down here, okay? And they were held in cages, unable to move, and they had these really like needles in their bodies, and they were inserted into their gallbladder, and they would be extracting bile out of the gallbladder, and they just pretty much stay there the whole lives. And as the bear creates more bile, they just take it out, and then they sell this bile on the black market as a type of medication. And so what she did is the next day she drew up a petition and started handing out flyers, and then within months thousands of people signed it. She delivered to the embassy in Canberra, and then she promoted with school children, fundraising events, and now she actually is the head of a organisation called Free the Bears, and she's set up huge sanctuaries in Cambodia, Thailand. She's rescued all these different types of bears, and she's actually removed so this is like a dancing bear, and people used to pay money for this bear to dance for them. She's actually been one of the key players to remove this kind of act going here in India by herself. So that's an amazing thing, and she was like 50 years old when she started it. So there's some really cool things you can do even as a normal citizen. So we're talking about environmental change, and one of the natural agents of change. So we've talked about how humans can change the environment. We've talked about how exotic pests really change the environment. Now we're talking about natural agents of change, which is fire. So fire is a natural part of the Australian ecosystem. And some species are actually adapted to living in fire-prone areas. So there's something called a vegetative reproducer that allows the top stems to burn, but underneath, so let's just say this is my land and this is my flower, okay, all this burns up, but underneath here the roots all stay alive, okay, in the soil, and then after the fire's gone through, the underground stems just shoot up and they can grow again. Some are obligate seeders, which plants don't survive the bushfires. Their seeds, however, do survive, and some of them only split when they come in contact with the fire. So this is here. This is an obligate seeder, and the plants here don't survive, but these seeds open up because the heat actually pops them open. So once the fire's gone through and it's gone really hot, then after a while they'll pop open and then they can germinate. So native plant distribution is greatly affected by how often a fire goes through. So if you've got lots of fires, you've only got these small shrubs and grasses usually dominate the landscape. But if you've got not many fires, all the shrubs can grow up and they become lots of big, tall trees dominate. So sometimes absence of fire actually affects an ecosystem. So with the golden-shouldered parrot here, these are really rare and they're beautiful Aussie birds that relies on fire to burn shrubs that outcompete with grasslands. So you've got these shrubs here, and then what happens, right, is grass will grow, and if a fire goes through and burns out this shrub, then the grassland can grow, and it provides a place for termites to live, which is a food source for the parrots. But if there's no fire and you've got these shrubs growing, then all the grass starts to die out, and then all the shrubs start to grow, and then the termites won't go there anymore. Then you've got mountain ash trees. These guys drop seeds to reproduce, and it relies on fire to burn out lower ground trees that may block out new light for seedlings. So let's just say this is my big forest. Okay. And they're dropping a seedling down. Here we go. There's a seedling. Now, if there are smaller trees here or shrubs, this little seedling won't have any sun. Okay, because it's blocked out and they can't actually get any sunlight, so that will die. But if a fire goes through all of this, then the seedling will have the sunlight and will start to grow to be another tree. We'll talk about succession next time. Hopefully, actually we'll do it in your next lesson. So anyway, guys, I hope you've been able to complete your notes for chapter 16. You guys are doing really well, and I hope you're enjoying the first term of biology. All right, thanks so much and have a good day.